Welcome to IM1 8.2. The topic is measuring and constructing segments. There's 5 boxes for us to talk about. So let's dive right in, and I suggest you grab the notes and just kind of follow along with me. Okay, the first idea here that we're going to talk about is this idea of something called the ruler postulate. And the ruler postulate, I want to make sure you understand, when you see the ruler, when we think about ruler, we think about something that is measurable. So the ruler postulate means that we're going to measure something, and postulate just means a rule. So ruler, we're going to measure something, and a postulate just means that we have a rule that comes along with it. So we're going to measure something using a rule. Okay, there are 2 parts to the ruler postulate that we want to cover. The first part is the coordinate part, and the second part is the distance part. So let's first talk about the coordinate part, okay? So if I were to have a line, and I'll give myself a line like this, maybe a little more, and I'll give myself 2 points on that line. I'll call it A and I'll call it B. Well, the coordinate part of the ruler postulate says that all the points on a line can be matched to the real number system. So I could just call this point A, and I could call this point B, and I could match those 2 numbers in the real number system. That's really all it says. And then the second part is the distance part, meaning that if, again, I were to draw a line and give myself points on that line, so I'll call it A and I'll call it B, okay? And I assign a number of the real number line to those points, like for example, let's say A is at 5 and B is at 9, then the distance between points A and B is just the absolute value of their difference of their coordinates. So for example, if I'm looking for the distance of AB, and that's how we would represent it, it would be the absolute value of the difference of their coordinates. So 9 minus 5, of course, that's the absolute value of 4, which is just 4. So we can say that the distance is worth 4 based on the ruler postulate. So the ruler postulate, all it says is that we can match the points on a line to the real number system, and then we can use those real numbers to calculate a distance. That's really all it says for box number 1. Okay, box number 2, let's do an example of the ruler postulate. It says measure the length of ST, line segment ST, to the nearest tenth of a centimeter. Okay, so because the ruler postulate of part 1 says that we are allowed to name these points, I'm going to name point S at 2 centimeters, which clearly is what it is. And I'm going to name point T at, if I bring this down, I'm going to call that 5.4 centimeters. So I'm allowed to name the points, which I just did, S and T. We can match those points to a number on the real number system, so 2 and 5, and then we can find the distance or the length of line segment ST by simply just saying, well, we know the distance of ST, denoted just by a capital S, capital T, is the absolute value of the difference of their coordinates. So 5.4 minus 2, which is just the absolute value of 3.4, which is just a distance of 3.4 centimeters. That right there is your ruler postulate. Okay, that's what that means. So there's an example of how we use that ruler postulate. So it's not too scary, not too crazy. That's really all it wants you to do and understand. So that's box 2. Okay, box 3 is all about something called congruent segments. So I want to begin by making sure you understand what these words mean. When you see the word congruent in your brain, I want you to think that means same size, same shape, okay? And when you see the word segment in your brain, I want you to think that's just part of a line. So congruent segments are parts of lines that have the same shape and same size, okay? So let's fill in the blanks here together for the definition. Congruent segment means segments that have the same length. Just exactly what we said it was up top, right? So congruent segments means segments that have the same length. Now in mathematics, there's a symbol for congruent, and the symbol that we use for congruent is an equal sign, and then on top of the equal sign is like a squiggly S, like a sideways S. So that symbol right there is the symbol for congruent. So let's take a look at this little example over here, okay? I've got line segment AB, and I have line segment CD. The reason I can tell that these are congruent is because they are marked with these little red hash marks here. That doesn't have to be red, but just saying that they are the little lines, that tells me that AB and CD are the same length. So we say that line segment AB is congruent to line segment CD. So what does that mean? Well, it means this. It means that the lengths are equal. So AB is equal to CD, equal to, and then segments are congruent. The segments of AB and CD are congruent to each other. So there's equal, lengths are equal, segments are congruent. And that's really everything you need for box number 3. Okay, box number 4 is something called the segment addition postulate. So let's talk about these words, right? Segment, we already know. Segment just means part of a line. Addition, you're very familiar with that word. That just means to add or sum together. Postulate is a rule. Okay, so segment addition postulate means a rule that we can add parts of lines. It's a rule that we can add parts of lines. Okay, no problem. Let's dive into what it means a little bit more formally here. So take a look at this picture. I have a line, and I'll make sure you see it. So I have a line, and that line has a couple of points on it. It has point A, point B, and point C. Okay, this right here is the distance from A to C. This is the distance from A to B, and this is the distance from B to C. So you can see kind of how the whole thing is brought together. So let's fill in the blanks here. It says if blank is between A and C. So if B, so if this point right here, so if B is between A and C. So if B is a point that's in between A and C, then it must be true that the total distance A to C, so the total distance from A all the way to C is equal to the sum of its parts. So it's going to be A to B, right? So that's this guy here, plus B to C. And that's what that means. So if B is between A and C, then it means that the total length of AC is nothing more than the sum of the individual parts, AB and BC. And then the reverse of that is true. So it says if we know that AC, segment AC, is equal to AB plus BC, then it must be true that B is between A and C. So the reverse or the inverse of this is also true. And this is what it means to understand the segment addition postulate. And we're going to do an example in just 1 second. All right? Okay, so here is an example. Box number 5 is the last part of this lesson. It says, here's an example of the segment addition postulate. It says, using the segment addition postulate, find the length of DF. Okay, so we are interested in this length right here. So for part A, we're going to say, okay, DF is equal to DE, this part, plus this part, plus the other part, which is EF. So pretty standard. Okay, so DF is equal to, the length of DE we're given is 23, and the length of EF is 35. So therefore, it looks like DF is nothing more than 23 and 35, which happens to be 58. Okay, so there's part A. And then part B says, let's find GH. So it only wants this part right here. Okay, that's what it wants. So using the ruler postulate and the segment addition postulate in conjunction, we can say, all right, so the grand total, right, FH is equal to FG plus GH. And it wants me to find GH, so I'm going to go ahead and solve for GH by itself first. So I'm going to subtract line segment FG from both sides of my equation, and I would have this. FH minus FG is equal to GH, and that's the thing that I'm looking for. Well, FH I know is a grand total of 36. So if I look here, all the way from F to H is a grand total of 36, okay? FG is this little part right here, 21, and that's going to be the length that I'm looking for. That's going to be my GH. So 36 minus 21 makes 15. So 15 is worth GH. So that's how long GH is. And that's it. That's everything you need for 8.2. Let me know if you have any questions.